This is a continuation of the Chapter 7 review, beginning with Problem 9. In Problem 9, we have yet another quadrilateral that's in a coordinate plane, and for this one, we're only given 3 of the vertices, and we're charged with finding the 4th vertex. So let's go ahead and pull up that quadrilateral plotted in the coordinate grid. And here we can see that we have J, K, L, and M should be somewhere in this vicinity. Now, we have several methods we can use to find this. The one I think I'm going to pick is to exploit the fact that the opposite sides of a parallelogram are parallel. So, given that this segment, JK, has to be parallel to LM, LM has to have the same slope as JK. So this one has a negative 1, 1, 2, 3, 4, a negative 1/4 slope. So if I take this point and I move over 1, 2, 3, 4 and up 1, that should be point M, which would be 2, negative 2. Now, just for verification purposes, let's go ahead and find the midpoint of this, which is 5 plus 2, that's the average of the axis, over 2, and 3 plus a negative 2 over 2, which gives us 7 halves 1/2. Now let's do the same thing for JL. So we have 1 plus 6 over 2 and 4 plus a negative 3, so 4 minus 3 over 2, which is 7 halves and 1/2. And in fact, they're the same point. So yes, our coordinate of point M is 2, negative 2. And now on to problem 10. In problem 10, it says, state which theorem you can use to show that the quadrilateral is a parallelogram. Well, here we have opposite sides are congruent. They have the same measure, so they must be congruent. So the theorem says, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. That is the parallelogram test, opposite sides converse theorem. And now for problem 11. In problem 11, we have the diagonals appear to be bisecting each other. This is congruent to this, and this to this. So yes, these diagonals are bisecting each other. The theorem that tells us this is, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And that is the parallelogram test, diagonals converse theorem. Now for problem 12, here we have opposite angles that are congruent. In this case, this theorem is very similar to the opposite sides theorem. It's the parallelogram test, opposite angles theorem, which says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Again, that's the parallelogram test, opposite angles converse. In problem 13, it says find the values of x and y that make the quadrilateral a parallelogram. This is using the converse theorem, so these two sides and these two sides must be mutually congruent in order for this to be a parallelogram. So let's go ahead and solve this. And we have for 13, we know that 4x plus 7 has to equal 12x minus 1. So subtracting 4x from both sides, 7 equals 8x minus 1. Add the 1. 8 equals 8x. Therefore 1 equals x. And now working with the y's, y plus 1 has to equal 3y minus 11. Let's subtract the y from this side. So 1 equals 2y minus 11. Add the 11. 12 equals 2y. 6 equals y. And now on to number 14. Here we're dealing with the diagonals must bisect each other. So this is the bisecting diagonals converse. So this piece has to be equal to that piece. So for 14, 6x minus 8 has to equal 4x. Let's go ahead and subtract the 4x. 2x minus 8 equals 0. Add the 8. 2x equals 8. Divide by 2. X equals 4. And now on to number 15. In problem 15, we're told to show that quadrilateral WXYZ is a parallelogram. So let's take a look at what the parallelogram looks like. And we can see, oh, it looks like one, but never fall into the trap, never trust the picture. So in order to determine if this is a parallelogram, this side has to be parallel to this, and this side to this. Now, even though it's not essential for you to graph these out, it's really handy in this particular case, but you can't trust this because you're not going to have something as nice and clean as this. And so we're just going to use the slope formula to determine if this is parallel to this and this to this. So away we go. Let's go ahead and do the slope of WX first. So it's the difference of the y's, 8 minus 6, over the difference of the x's, 2 minus negative 1, which gives us 2/3. And this is for WX. Now let's do YZ. So we have the difference of the y's, 0 minus negative 2 over 1 minus negative 2, which is 2/3. And this is YZ. Okay, so these are clearly parallel. Now let's work on WZ and XY. So WZ is 6 minus negative 2 and negative 1 minus negative 2, which gives us 8/1, which is 8. And this is WZ. And then let's do XY. So XY is 8 minus 0 over 2 minus 1, which is 8/1, which is 8, and that's XY. And we can see that both of these are parallel to each other, and therefore, yes, in fact, WXYZ is a parallelogram. And now on to problem 16. In problem 16, it says classify the special quadrilateral and explain your reasoning. So let's take a look at this picture. We can see that we have all four sides are congruent. So we know at the very minimum it has to be a rhombus, because a rhombus has four congruent sides. Now, the other requirement is the angle measures. Now, if this were to be a square, all these angles would have to be 90 degrees, and in fact they're not. This one's 56, so this one cannot be a square. This one must be a rhombus. Again, the reason, it has 4 congruent sides, but the angles are not all congruent, so it can't be a square. So let's just say that 16 is a rhombus. Alright, now let's look at 17. In problem 17, we have 2 sides are parallel, 2 sides are parallel. So at the very least, we know that this is a parallelogram. Now, we cannot trust the angles here. We can't trust the picture for the angles. So the only information they're giving us is that these sides are parallel, so this must be a parallelogram. That's as specific as we can get. And now for the last one, we have 4 congruent sides again, just like we had over here. But in this case, this angle is 90 degrees and this angle is 90 degrees. Well, since these 4 sides are congruent, we know that it has to be a parallelogram because it's at least a rhombus. And these have to be supplementary because they're consecutive angles. This one's 90, that one has to be 90. So all 4 angles are congruent. So in 18, this must be a square. And now on to problem 19. In problem 19, it tells us find the lengths of the diagonals of rectangle WXYZ, where WY equals negative 2x plus 34 and XZ equals 3x minus 26. Now, if you're like me, you need to draw pictures. So I'm just going to draw a quick picture here. So we have a rectangle W, X, Y, Z. It says WY, so WY is, oh, that's a diagonal. So WY here is negative 2x plus 3, 4, and XZ, the other diagonal, this guy is 3x minus 26. So that's one of the reasons why I wanted to draw the pictures, because now I saw that they're diagonals and not sides. So because they're the diagonals, I know that they must be congruent in a rectangle. So I know that 3x minus 26 equals negative 2x plus 34. Add the 2x, 5x minus 26 equals 34. Add the 26, 5x equals 60. Divide by 5, x equals 12. So it's asking us to find the lengths of the diagonals. So we've got the x value. Let's go ahead and substitute it in here. So 3 times 12 minus 26 gives us 10. And you could go ahead and compare this one as well. So negative 2 times 12 plus 34, that gives you 24. Negative 24 plus 34 gives us 10 again. And now on to problem 20.